Hello everyone, welcome to week 6 of Codivate Python class. Our topic for today is loops. The first type of loop that we're going to be looking at is the while loop, and these are just loops that involve conditions. Alright, the syntax for a while loop is similar to that of an if statement. We have the while keyword to let the compiler know we want a while loop, followed by a condition, followed by a colon. The condition in this case is just going to be a Boolean expression that evaluates to true or false. After this line, we have some code inside an indentation. Inside this indentation, we have what will be executed inside the loop. The difference between a while loop and an if statement is that the while loop will repeatedly execute this code until this condition becomes false. Alright, let's move on to the next slide. Since, as we saw on the last slide, condition is a Boolean expression, we can replace it with the keywords true or false. Or we could just do it with any other expression that evaluates the true or false. If we have a while true, and then inside we have print hello, we get an infinite loop because the condition true can never be false, so we never exit the loop. And we will keep printing hello forever. And this will keep going in your REPL.it. And if you want to stop it, you have to go to the top of the page and click this stop button. Otherwise, your code will crash and you will most likely have to refresh your page. On the other hand, we could also have a while false loop. However, this is a pretty useless piece of code because the code inside is never executed. Remember, the code inside is only executed while this condition is true. We have an infinite loop and a loop that never happens. On our console, we would have nothing printed because we never enter the loop. Our next topic for the day is iteration variables with while loops. If we want a while loop that executes a certain number of times, we need to create and update a loop variable. In this case that we have here, the loop variable is count. It initially has a value of 1. And our condition for the while loop is count is less than 4. As we learned before, whatever is inside this will continue to be executed until this condition is false. So count has a value of 1, we enter the loop. Well, count is less than 4, so we can actually execute these lines. So we print count, which has a value of 1, onto the console. So we have in this first line. Then we increment count by 1 using the plus equals. Now count has a value of 2, and we jump back to the top of the loop. We check to make sure the condition is true. 2 is less than 4. Well, that's still true, so we go back in the loop, print the value of count, which is now 2, and increment it by 1 again. Now it has a value of 3. We check the condition, still true. We print it again, right here, and we increment it by 1. Now, count has a value of 4. So we go back to the top of the loop, but this time we notice that 4, which is the value of count, is not less than 4. And since this condition is now false, we exit the loop, and we are done with execution. Let's take a look at the visual execution just to see what happens. So initially, count is 1. We make this variable count, assign it a value of 1. We enter the loop since the condition is true. We print the count, increment it by 1. Make sure the condition is true. Print it again, increment it. Make sure condition is true. Print it, and then increment it. So this is basically the process that the computer uses to execute a while loop. Let's go back to our presentation. So the next topic for the day is break and continue. So these are some keywords that are useful for writing while loops. What we did before, we can do it in a different way using break. Instead of having the condition right next to the while, what we could do is start off with while true, which will basically create an infinite loop, and then somewhere inside our loop we have a condition that tells it to break. So what will happen here? We have a while true, meaning this will execute forever and ever and ever until we break out of it, which is what this keyword does. So let's enter the loop and execute it. Count initially has a value of 1, and since this is true, we enter the loop. If count is greater than 3, well, it's not, so we don't do anything inside here. We print it and increment it by 1, we printed it and it now has a value of 2. We check again, is the value of count greater than 3? Well, only has a value of 2, so it's not. We print it and increment it again, it has a value of 3. Is the value of 3 greater than 3? No, 3 is equal to 3. So once again, we print it out and increment it by 1. Finally, after that last incrementation, count now has a value of 4. And since that is greater than 3, which is a true condition, we enter our if statement and break. As soon as Python sees this break, it will exit the while true loop and stop executing. So that's what the break keyword does. The second keyword is the continue. What continue does is it will stop the current iteration and skip to the next one. So let's take a look at our example. Count has a value of 0. While its value remains less than 10, we are going to execute these set of instructions. First, we increment it by 1. So 0 plus 1, it now has a value of 1. We check this condition. As we learned a couple weeks ago, this condition basically checks if the number is even by seeing if the remainder when we divide it by 2 is equal to 0. Since 1 is not an even number, we don't go inside here. You can think of this condition as, is the number even? Is count even? And since count is not even, we don't execute this continue, and we just print out the current value, which is 1. Go to the next loop. Now, we increment count by 1 again. Has a value of 2. It is even, so we do continue. When we do continue, we skip this print and go back to the top of the loop. We're still inside less than 10. 2 is still less than 10. So we go to the next iteration. Now, it's going to have a value of 3. It's not even, so we don't continue, and we actually go to the print. We print it out since we got to this point. We'll have the 3 now. Go back to the top of our loop, make sure it's still less than 10, increment it by 1, so it now has a value of 4. And since 4 is even, we continue, we skip this print, and go back to the top of the loop. As you can see, we're beginning to have a pattern here that it's printing only odd numbers. And since we know the condition is count is less than 10, this will print all the odd numbers from 1 to 10. Alright, this is a very important algorithm that is used in Python for user input. This is how we would combine while and try and except, which is what we learned about last class. We start off with a while true, and we ask the user for an input. So what this code segment will do, before we go to the try and except, is that it will repeatedly ask the user to enter a number until it's actually a number. So we want them to enter a number to square. So they enter a number and we store it to the value of num. Remember, we have to use our input function. Then we try to print the number cast as a float, and then we try to square that. If that works, we break out of this entire loop, and we are done. However, in the case that this causes an exception, or this would cause an error, because we don't know if we can cast this num to a float. What if they just entered a string or a bunch of symbols? Then we cannot cast it to a float, and this would cause an error. As we know with try and except, if this causes an error, we go to the except block. And inside the except block, we print, please enter an actual number. Let's take a look at this example of the code being run. We see the input, enter a number to square. We enter 8, but written in an alphabetical form. Since this is not a float, Python tells us, please enter an actual number. It tried to cast it to a float and square that, but it couldn't do that. So it went to the except and told us to enter an actual number. We do this again with 4, we still get the except, please enter an actual number. And once we finally enter a number that we can square, which is 7, this try block executes successfully. And since we can cast it to a float and square it, remember these double asterisks means square, we break out of the code and we are done. You can see 7 squared is 49. You can wait for that pop-up to go away, and you can see it says 49. Let's put some practice with while loops. So you can pause the video and try to do this prompt. Write a program that uses a while loop to remove all the occurrences of 13 in this num list. Let's say num list has all these values in it. So I'm assuming you pause the video and try to answer the question. Let's take a look at the solution. First thing we want to do is create our num list that has all these values, because it'll be useful when testing our code. So this is the while loop that we used. While 13 in num list. So while there is a 13 in this list, and then inside our loop, we use the remove method on the list. And as you remember from a few weeks ago, the remove method will remove a certain value from the list. It'll remove the first occurrence of 13 from the list. So while there's a 13 in the list, we will continuously remove 13 from the list. This will keep repeating until all the 13s are gone, and once we print our num list, you'll see that there are no more 13s, only the numbers that are not 13 remain. Let's take a look at another solution. So we could also loop through each index in the list using a while loop. We'd set the initial index to 0 because that's the first index, and we'd keep looping till the end of the list by setting the condition to be less than the length of the num list. Because remember, the length of the num list will be outside of the list if it were an index. So we make sure that we're less than that length. So while we're less than that length, we check, is the current item, this is how we access the current item in a list, using the loop variable as the index, is equal to 13. If it is, we have to pop that index out, and we have to decrement our I by 1. The reason we have to do this is because as we get rid of a 13, our list gets shifted to the left. So we also have to shift our index to the left to keep up with that. Otherwise, if there's nothing, and also once we finish executing this, we have to increment our I by 1, so we go on to the next index. Since this is a loop, it will keep iterating until we get to the end of the list. And we have the same output as before, which is what we wanted, the entire list without any 13s. This is another way to do the problem. We have our num list as usual, but this time we're starting at the end of the list and going backwards. Our last index will just be the length of the list minus 1. And while I is greater than or equal to 0, which will be the first index, since we're starting at the end and going to the front, we want to make sure it's greater than or equal to 0, which is the first index. Our code inside is very similar. We check if the current item is equal to 13. If it is, we pop it out. The only difference is that since we're going from the back, we don't need to account for the list shifting. And the only thing we need to do is update our loop variable by decrementing by 1, so we go backwards throughout the list. At the end, if we print our num list, we get the same result, which is correct. Alright, we made it through while loops, and there's another type of loop in Python called the for loop. Let's learn the syntax for this loop. If we want to loop over a code segment a certain number of times, a for loop is the best choice for the scenario. We use the for keyword to start the loop. We then use a loop variable. In this case, we called it I. Then we use our in keyword, and after that we use the range function. So what the range function does is it basically creates a numbers from 0 to n-1. That sounds a lot like all the indices in a list. We'll get to looping through lists a bit later. So, since this will be creating the numbers from 0 to 4, we will basically loop, and I will take on all the values from 0 to 4. Because remember, we have to do n-1 here. And each time it will print, this is iteration, and concatenated to that, it will print whatever the value of I is plus 1. If we print this, it would have, this is iteration 1, 2, 3, 4, and 5. So I is taking on all the values from 0 to 4, but since we're adding 1 here, it takes on all the values from 1 to 5. That's how the range function works. It starts at 0 and takes on the value of each number from 0 to whatever this is, minus 1. Let's take a look at the visual execution for this. We started with our for loop, and I initially has a value of 0, which is the loop variable. And then we print, this is iteration 0 plus 1, this is iteration 1. I now has a value of 1. We print, this is iteration 1 plus 1, so this is iteration 2. I now has a value of 2. We print, this is iteration 2 plus 1. We do this until we get to 4. And our last line would be, this is iteration 5. Alright, let's go back to our presentation. Now let's go how to loop through lists. Let's say we have a list called temps, and we want to print each value in it using a for loop. We want our loop to work for any list, so even if we have a list of different length, we want it to work. So how would we do this? Well, we can specify the range to be the length of the list. When we index a list, the first index is 0, and the last index is the length of the list minus 1. When we use our range, we go from 0 to whatever we input minus 1. So if we want the parameter to line up with the index, we can just use the length of the list for the range parameter here. So our code would look like this, and once we print it, the output would have all the items in the list on a separate line. Another way to do this is using a for loop like this. And what this is basically doing is creating a temporary variable that will take on the value of each item in the list. This is called a for each or an enhanced for loop. What it basically is saying is that for each temp in temps, so each value in this list, print the value. However, we should know how to use the first method as well, because it allows us to modify the list. This may seem easier, but this one actually allows us to change the list, but this one does not. And one more note about this one, as we know how to access items in a list using the square brackets, I is just taking on the index values for each one of these, so we would have I inside the square bracket here. This is what I mean when I say we can't modify values using the for each loop. If we try to set each value temp times equals 2, and we wanted to multiply each value by 2, even if we tried doing something like this, even after printing it, nothing changes. Everything stays the same. And the reason why this happens is because temp is just a temporary variable that is created for the purposes of the loop to access each item. It doesn't actually change anything inside the list. So it'll be multiplied by 2, but it won't really be stored back into the specific index of the list. If you wanted to actually multiply everything by 2, it would be better to use the first type of loop that we learned using the indices. Just another application of these for each loops is printing each letter in a string. So our loop variable here is letter. Once again, you can call this anything you want. It doesn't necessarily have to be letter, but in this case we chose letter because it models the situation well. And if we run this code segment, it'll print each letter inside this string on a separate line. Let's get some practice with for loops. Our task is to write a for loop that goes through a list and finds the smallest value in the list. Before we start, and I give you time to work on this problem on your own, let's think about how we would logically find the answer if we were the computer. We would look at the first value in our list. So far, that is our minimum value. Then we would look at 0. Well, since 0 is less than 9, that becomes our new minimum value. Go to the next item. Negative 3 is less than 0, so that is our new minimum. Next item, 5 is not less than negative 3, so negative 3 is still the minimum value. Same thing for the next one, 98 is not less than negative 3, so negative 3 is still not the minimum. Negative 3 is still the minimum. Finally, negative 47 is the value we look at. And since it is less than negative 3, it becomes our new minimum. So the minimum in this list is negative 47, and we have to loop through each item and check if it's less than the minimum so far. So how would we take this procedure and apply it to Python code? So this is basically the procedure we have to follow in Python. We create a variable to store the minimum value. We'll start off by assigning it the first value in the list, which will be our minimum so far. Then we loop through each item in the list, and if the current value is less than the minimum value, we assign that min value variable the value of the current item. Once we're done with this entire looping process, we print the min value variable just to confirm that we have the correct answer. So now would be a good time to pause the video and try to solve this by yourself. I'm assuming you had a go at it. We will go over the solution now. So the first step was to create a variable that stores our minimum. We have a variable called the min value. And what we wanted to do is assign it the first item in the list, which we can do by using the list name, numList, and the square brackets and put 0 inside, which would represent the first item in the list. Now we need our for loop. We want to go through each item in the list. We have our loop variable I. We use the range. And inside the range function, we put the length of the numList because we know this is how we make a loop to loop through each index in a list. Inside our loop, we check if the current number, which is going to be numList I, is less than the minimum value. If it is less than the minimum value, that becomes our new minimum because we assign min value to the current value, or min value, the value of the current value. We keep looping through the list and repeat this process. As soon as we see something that's smaller than our min value, we assign whatever that smaller thing is to our min value. Once we're done with this for loop, we should have the minimum value stored in this min value variable. Once we print it, we can confirm It indeed is negative 47. So the last topic for the day is nested loops. Nested loops are used to loop through items in two-dimensional lists. So before we get to nested loops, let's talk about what two-dimensional lists are. So basically, two-dimensional lists, or a 2D list, is a list of lists. Here in our example, we have some regular lists that have some strings. The primary list has red, blue, and yellow, and we also have other lists that have strings. And this color groups list is the two-dimensional list, because inside this list, we have a bunch of lists. You can basically think of a two-dimensional list as a list of lists. So if you were to print out this color groups list, it would have these outer brackets for this list. You can see the outer brackets here. And inside, we will have each of the lists. This is the primary list, the secondary list, and the neutral list. It's basically a list of lists. That's the main takeaway when it comes to this slide. So if you wanted to go through each item in a 2D list, we would need nested for loops. We can look at both ways to do it. We can use the range function, and we can also use the enhanced for loop feature. So the first way, using the range function with len, we would go through each list in the bigger list. So we'd be going through each one of these, primary, secondary, neutral. And inside the inner for loop, we'd be going through each item inside the smaller lists. One thing to remember is that we should use different loop variables for each of these. And inside, we would use our square brackets to access the lists. Here, we have length of the color groups of I, because that just wants to confirm that we are looking at the length of the current list, because each list may have a different number of items. In this case, it just works out so it's the same, but it's possible that we have different number of items in each of the inner lists. The second one is a bit more easier to understand. We're basically going through each color group in the color groups list, which will be primary, secondary, and neutral. And within each of those color groups, we'll also be going through each color. This is just an enhanced for loop. Basically, for each list in the list of lists is the outer loop, and the inner loop is for each item in each list. The output for them would be the same. We're just printing all the items in the two-dimensional list. Alright, let's move on to the exercises for the day. Now would be a good time to pause the video, read these exercises, try to solve them, and once you're done, come back and see the solutions. I'm assuming you attempted the exercises, so let's go through the solutions now. So in the first exercise, what we want to do is create two sorted lists from a list of strings and ints, and one of the sorted lists should have ints and the other one should have strings. A good way to test this is to create your own list, one that has both strings and ints. Another thing we want to look into is that the program should work for any list, so this is a hint that we should use the length instead of just the specific length of the list. One of the ways we can approach this problem is to use try and accept. The other way, which might be easier, is to use the type function that we looked at recently. The example goes through this weight that involves using try and accept. We have our mixed list that has some strings and some ints. We also make two new lists, two empty lists, that we are going to be storing all the nums in one of them and all the strings in the other. Something interesting you may notice here is that we are declaring two different lists on the same line. we can do this in Python as long as we separate the variable names and what we're assigning to them by comma. Now we're just going to loop through each item in this big list, this mixed list. What we're going to do is try something with the list. We try to square the current item. Well, if we can square it, that means it has to be an int, because we can't square a string. And in the case that we can square it, we append it to the num list, which is basically adding it to the num list. However, if we square it and that causes an error, that means it has to be a string, because we know that if it caused an error, it cannot be an int, and the only other possibility is a string. So in that case, we append it to the string list. We do this for each item in the mixed list since we have our loop here, and once we're done with that, we just sort both of these lists using the .sort method. At the end, we can print both of our lists, and you can see that it has the correct output. 1, 3, and 8 is sorted, and we have 4, A, and B. One thing you may notice here is that numbers come before letters alphabetically when they're strings. The other way to do this would be to use the type method, type function, and then just check if the type is equal to string, add it to the string list, or append it to the string list, and if the type is int, add it to the num list. Alright, so exercise 2 was to use a while loop to double each item in the list. We have our num list. Initially, we need to set our loop variable equal to 0. I will basically be taking the value of each index. Our indexes start at 0 and go to the length of the list. But we stop just before that because the length of the list, that index would be out of bounds. We have our while loop set up, and inside the while loop, we look at the current item in num list using the square brackets and our loop variable, and we multiply it by 2 and assign that to whatever its current value is. Times equals 2. That's the increment operator we looked at a few weeks ago. And once we do that, we increment I by 1 to go to the next item in the list, the next index in the list. We repeat this for each item while we are inside the list. Once we're done, we print the num list. We can see that our outputs are correct. 0 times 2 is 0. 0.5 times 2 is 1. 0.5 times 2 is 1. 1 times 2 is 2. And since we have to double each item in the list, we know that we did this correctly. Alright, that's it for this week. If you have any questions, you can reach out on the Discord. And stay tuned for next week's lesson.